So here we are in Unity. Before we look at the assets, I'll just take a quick look at the project settings. A few things that you need to get sorted first. You want to make sure everything is working in the .NET scripting backend, runtime version and compatibility level. Another unusual setting is defining the symbols here as SSL. This is important for the client to work. In the publishing settings, we want to make sure we have the internet client and Bluetooth checked. It's a good idea as well to set a package name. In the build settings, we'll switch to the Universal Windows platform. We'll run this on any device, 64-bit architecture and D3D build type. We'll check C# projects. This is helpful later in the Bluetooth scene, but it's also nice to inspect the post-build files. And we want to add the open scene, which is green brick. This is our starting scene. We also have a few other assets here. In the Arduino folder, there is the sketch that I showed you earlier, and the dependencies are also there. The M2 MQTT folder contains all of the functionality for the message broker and the sending and receiving of messages. In resources, we have an FBX that you can see in front of you here. This is a Lego brick, and some pointers. We'll use these for general interaction later. The scenes and scripts are also here. We'll just be using the scripts that are inside the green brick folder at the moment. Going to the hierarchy, we can see that we have a canvas-based user interface. This is running on the screen space. If we wanted to make this more three-dimensional, we can change this to world space at the risk of losing some parts. You can see that I've moved this to one side to allow this three-dimensional brick, which is actually down here. And we'll be linking the IMU movement to this brick later to move it around. Finally, there's the M2 MQTT entry. This is the entry point for the script. You can see here that we've specified the broker address as this same test service that I described earlier, and this is the default port. So let's begin to look at the code that's running this MQTT client. The most sensible place to start seems to be the script that is attached to this game object. And in here, a few changes were made in order to get this working. There are two private variables that have been set. One is for a sensor data handler, which is a new class that I've written, and the other references a game object, that is the brick. These two functions at the top of the code are high-level functions that affect subscription and publication to the broker. One very important point is the designation of the wikit/vest topic here. When we're subscribing, we are subscribing to this topic, and that was the one that was also named in the sketch. Below this, there are some lower level state changes, and at around line 200, we are instantiating both the sensor data handler and we are linking the brick game object to the object in the hierarchy. So in Unity, when we want to understand how code is behaving, a good place to start is usually the update loop. And we can see here on line 249 that the main event that is happening each frame is the processing of messages. When this happens, the UI is given a new string, which is the message that is received. And what I've done is to add two other lines after that, the first of which establishes a quaternion, which is a state of rotation, and it's taking a value from a function that is in the sensor data handler, and we'll look at that in a moment. Having got that quaternion, we set the local rotation property of the transform, and that's it. We're able to visualize the quaternion that's coming from the message with the brick in just a few lines. So let's go one level down and have a look at the sensor data handler that is providing this information. This class, also very simple, has a single variable, and this is a snapshot of the data that's coming through, and we would expect there to be many of these per second. The single function just has three parts to it. The first is an instantiation of the data frame, a new data frame. The second one uses the JSON decoder. It's turning a string into a set of objects, each of which has a value which is defined in the data frame, and that's the lowest level we'll look at in a moment. Finally, what this function is doing is taking four numbers out of that data frame. We are disregarding all of the others for now, and sending them back to the original function. So let's look at the data frame. Again, a lot of this is taken from the WeKit platform, and so we won't be needing it for this example. But you can see that the IMUs form part of a list, and each IMU has values for acceleration, its gyroscope, the magnetometer, and also a four-part quaternion. And it is these four numbers that we are taking out later on and passing them back to the interface. So we're nearly ready to test the code. The only thing we need to do is plug in the IMU into the ESP32, and that's what I've done here. And I've got a short USB cable. So I'm going to plug that into the computer and wait for a few seconds for the sketch to load. When the sketch is happy that enough figure-of-8 waving has taken place, it will display on its screen a title of Suit 1.4, and if you've configured it correctly, you should be able to see your local IP address on the screen. It will tell you that Bluetooth is off at the moment, and it will have a ratio showing you how many bytes are being sent. There is also a timer to count how long the sensor has been active. If all this is working well, then we can run our Unity scene. Once the scene is running, we should check that the broker address and port are correct, and then we can test. The brick has a slightly jerky movement, and there's certainly some data loss, but that may be to do with the public services running on the Mosquito server. So there you have it. There's a live IMU connection into Unity. If you want to make this mixed reality toolkit friendly, you should change the camera to a mixed reality camera parent and add the mixed reality to the scene as you would for any other application. All of the settings in the project and player settings are fully compatible with that, so you shouldn't have any issue blending it together. We'll just take a quick look at the console log, and we can see from one of these the structure of the data packet that's being sent. This is the data frame variable that was built in the sketch, and we can see it has the top level objects of client, time, IMUs, and then it has the IMU values inside arrays. It's very important that you match the names of these. So where the first entry is client, in our data frame the name of the first entry should also be client. You need to make sure that this list corresponds very closely, or rather exactly, to the data frame that is being sent. This is absolutely critical, and you will find lots of errors if this isn't quite right. So with this done, we can now look at how we might convert this into a Bluetooth system.